Welcome to Three Devs and a Maybe. Now introducing your show hosts, Michael Budd, Fraser Hart, Lewis Gaines, and Ed Mann.
Hello and welcome to another episode of Three Devs and a Maybe. My name's Ed Mann, and today we're carrying on the conversation we actually started last episode with Scott. So enjoy. Moving back on very swiftly, onto the web application security, database interaction. And, you did mention earlier, the SQL injection attacks. I think, for a lot of developers, we're going to use prepared statements. We're going to use like PDO. And, again, it's splitting out that data and code. It's very interesting. You mentioned that, you can kind of see that through all these things that really is applicable. I'm just wondering at a fundamental level, though, what is a SQL injection attack?
So if you're using like modern approaches, if you're following modern tutorials, you probably won't write the code the same way that's vulnerable. But if you're using, tutorials written in like 2006 or you were just around back then, this might be more familiar to you.
I was that guy.
So once upon a time, developers used to take like get parameters, like get, ID, and combine it with the SQL query to, like, if they wanted to have an interactive application, they would like fetch a user by their ID number or by their username and then display their profile. What SQL injection is instead of passing like a number, you would pass in like some SQL command, usually with a semicolon in front, or not a semicolon, apostrophe, like single quote. And that would usually break out of the current structure that was being built, and then you would put your own commands in there. You can do things like, if you are pulling in, one item at a time, you can say, I'm actually going to pull all of them instead of like a top 3 list. I'm going to drop the limit. I'm going to get everything at once. You can say, I want to actually, join this on the users table and get their password hashes. And you could do that. And suddenly you have a web page full of everybody's password hashes, assuming that they were hashed in the first place. So you could basically take any data in the database that web application has access to and steal it. More advanced attacks, you could write a file to the file system by saying like, union select some quoted string containing a PHP, malware into out file and then something in the document root. So generally, once somebody has access to your database, it's generally game over. There might be mitigations in place to protect things like your SSL keys, but most web applications, if you have read-write access to the database, you've got the keys to the kingdom. Especially if you can escape to the file system and get code to run on the server, then you can just run whatever malware you want, and it's not fun.
Yeah, absolutely game over. And so, how do you prevent this from occurring then?
So the old way of doing things was to escape it for like SQL command characters, like single quotes. That's not really effective because the people who wrote the escaping functions did it with good intentions. It is useful in certain contexts, but generally, if you're taking user input and you're combining it into a domain-specific language like SQL, you don't know how it's being used when you write the function. It's literally input-output. It's kind of dumb. You don't know the character set being used necessarily, especially with the old MySQL extension. So you have input-output, no context given. You don't know if it was user input or something from a trusted source or a hard-coded constant that just got mixed in with some other data based on some switch statement somewhere else upstream, and now it's safe. You're kind of operating blind. And the other problem is the developer has to be consistent and diligent. They have to always escape. If they miss it one time in a 100,000 line code base, you slipped up once and now everything's catastrophic. So the long-term scalable solution to this is what's called prepared statements, which is hopefully what everybody knows to use nowadays. If not, type in PHP prepared statement tutorial in your programming language you're learning in Google, and you will find something somewhere written by somebody who does not want your site to get hacked by SQL injection. It will tell you how to do it right. So there's two kinds of prepared statements in PHP. You have the emulated one, which is the default, which basically it does like the escaping, like string escaping, the whole MySQL real escape string thing, but it does it in the background. So it'll like you have a parameter for a placeholder, like you'll say like select from foo where column equals question mark. It'll replace that question mark with a properly escaped string, we hope, and send that all as one query, and you have one round trip. The problem is as I alluded to earlier, there were character set based attacks where if you ran a query that set your character set to something different than the database driver knew, you could actually inject meta characters. Like if you were, there was a long Stack Overflow answer that specified this in detail. If you type in bypass prepared statements on Google, you'll probably find it very quickly. But basically, it was one of the Asian character sets where one of the escape codes included the ASCII character for the single quote. So even if you were using prepared statements and you set the character set at one point, but it was set to like UTF-8 or something in the driver itself, and you injected this character, you could then treat it as a single quote with some junk after it, and then you've got escape access.
Again, game over. So what actually then is prepared statements then compared to emulated?
So prepared statement uses an API provided by the database software to prepare a query, exactly as on the label. And what it basically does is it'll send one packet, and it'll say, I want you to prepare this query that accepts these placeholders. And the database software in the background returns an ID for the prepared query and says, okay, use this and send your parameters separately. And then you can actually reuse this prepared statement and send, like, if you're doing a lot of inserts, like a huge batch insert into a database, you can just reuse the query with just pass different parameters.
And again, that's splitting the data from the code itself.
There is no input unless you find a buffer overflow vulnerability in Postgres that can alter the original string that was passed to the database server because it's separated completely. They're sent in separate packets. So I talk a lot in, whenever I do developer training or if I'm just talking online about code data separation as a security layer that is what I consider provably secure, because there's no possible input that alters the code that was being executed. You're just providing it with data. And that's far more secure than trying to tell people to, escape SQL injection and deal with cross-site scripting in this way, and then, deal with XPath injection this way, and remember all these mystical incantations you have to put in your code. Designing better APIs that make security easy to use is a more scalable and easy to digest solution. There's the OWASP Israel chapter has a member called Avi Duglin, who's very popular on Stack Overflow. And Avi has a law of usable security, which goes like this. Security at the expense of usability comes at the expense of security. And that's very true. If I expected people who, I mentioned Chronicle earlier, which was that append-only data structure that's very blockchain-y. It uses a protocol called Sapient, which is basically for communication between two API endpoints, you can sign or encrypt messages back and forth. And this is on top of what TLS provides. So like if you have a hard-coded public key for a service and you want to encrypt a message, or if you have a API provider you trust and you want to sign the message, or you want to verify the messages that they've signed, you can use the sodium cryptography features transparently in the background just by using Sapient. I wouldn't expect developers to write libsodium in their code, like implementing the Salsa 20 cipher, implementing the Poly 1305 authenticator, doing all the field arithmetic. I mean, if you look at the Sodium compat source code, you can see an implementation of that. It's not fun to try to write that from scratch. Instead, you have a simple interface that does this all in the background for you. View this that the same kind of idea applies here to prepared statements. You have a simple way of solving the problem without having to re-implement everything from yourself. And even emulated prepared statements are better than nothing, but I still advise against them because they don't have that property where the code is sent in one packet, and then there's an identifier, then it sends the parameters with that identifier in a separate packet.
I know that you've got like the EasyDB library and stuff. Is there a way of actually telling, like your database to use this or the driver to use this? Like, does PDO say, oh, I can use prepared statements with this version of Postgres, I will, else it'll fall back to emulated? Or do you actually have to specify it yourself?
You actually have to call the set attribute function on your PDO object. If you're using the EasyDB library, which sounds like it's 4 letters, but it's actually the word easy followed by DB, this does it for you if you pass a PDO object in the constructor. And if you try to, invoke set object on the library I wrote, and you try to overwrite the attribute to make it not use prepared statements, it'll actually throw an exception and basically saying, no, you can't do that. I've convinced putting a HAL 9000 reference in there, but I don't think a lot of people would get it.
And with like the emulated then, so is it a simple case of if I on my PDO set the attribute to a real prepared statement and everything should work as expected if I was to, similarly to how I was using emulated? is it, is it a like for like, or is there anything that needs to be kind of changed or to bear in mind if you're using a real prepared statement? Other than maybe a slight performance hit, I suppose.
Yeah, so if you're concerned with micro-optimizing your architecture, you might shy away from what I call actual prepared statements, because it does take 2 round trips to the database. First, you send the prepared query, and then you send the parameters. The overhead of a round trip on your database should be minimal, like in the order of milliseconds or even like microseconds.
And you don't want to have game over. It's better to have a little bit slower and be secure than game over.
Exactly. So that's my stance on it. And also, it does matter. Like I said, if you're inserting 1,000 rows into a database, that extra round trip, it doesn't become 2,000 round trips. Like, if you're going from 1 to 2, it goes to 1,001. And the second round trips actually have less data because you have an identifier in your parameters. You don't have the structure of the query. That's already negotiated.
And it just follows that rule that, you say, which is so true. The data and the code split out, and it's truthfully being that way. And it's almost impossible for them to actually, for it to be corrupted. And there's none of this context-based escaping and things that have to go on.
Yep. It makes the security posture of the situation boring. And that's the property that's actually desirable. You want your security and especially your cryptography to be boring, to where things are obviously secure and uninteresting to researchers.
Oh, that's so true. Moving on from that, file uploads. Now, file uploads are a scary thing in itself. Allowing a client not only to just send text, you're now allowing them to send an arbitrary file, binary stream, an image, whatever, I'm just wondering kind of like, what are the gotchas and maybe like things to bear in mind when you're allowing people to upload files?
So there's 2 big problems with file uploads. The first one, a bit of background. If you're accepting file uploads, you're allowing them to upload a file to your file system, even if you reject it afterwards. It's in your temp directory or whatever your equivalent is on your OS. And that is a bit scary, letting anyone on the internet write a file to your file system. Yeah, it's not fun. So that is scary by itself. But the big things people have is trusting data they shouldn't. Like if I send a file to a server and I tell you that the file extension's like .php but the the file type is image/JPEG, they'll just go, oh, it's an image. Okay, I'm going to drop it in the images directory. And that was actually a Joomla exploit back in the day, where if you appended a dot, it would bypass the filter and let you upload it. There was actually a talk at a security conference called B-Sides in Orlando. There's B-Sides conferences all over the place. This was the first year I went to it. And there was a guy talking about snort rules. This is a slight tangent, but I think this is an interesting story. And he was talking, he was doing demos of writing rules for this thing called snort, which just does intrusion detection. And at the very beginning of the talk, he says, feel free to interrupt me with questions at any time. I love it. He's demoing a rule to block this Joomla exploit. And I'm looking at this, and I've never encountered this Joomla exploit before. This is, something that was completely unknown to me because I was kind of in my own microcosm back in this period of time. And I looked at the thing, and I just said, so you're blocking .php. What if I upload a PHP3 file or a PHTML file? And he's like, well, this rule will stop 99.9% of attackers. Nobody's really going to send a .php file. And then everyone in the room just kind of like shuffled a little bit, and the person next to me was like, yeah, but he would.
Yeah, that's it. Exactly. All you need is one person. And this is the thing, isn't it?
Yeah, a lot of security defense actually looks like that. Like they'll block the .php file because that's the public exploit people are using. They don't stop and decontextualize what they're defending, usually because they have like 30 things to do that day, including like 20 vulnerabilities that are very high. They need to get a mitigation pushed out to stop clients from getting hacked. To go, well, what if they changed it slightly? Our detection wouldn't catch it, but they would still manage to get past it. And so that's an interesting field of research, is bypassing filters and security products.
Because I suppose it is just a filter, isn't it? So I need to know what your expected input is to catch you.
Exactly.
So it's a kind of, it's a chicken and egg thing there.
Exactly. So, yeah. So for file uploads, one of the problems is accepting, trusting what the data they give you is. Like if it's a MIME type or a file name, that might not match what the actual content is.
That's the thing, because you can spoof your MIME type, you can spoof your file extension. You're kind of at the mercy then of, really, you don't know what you've got.
Any data that comes over the wire can be spoofed. The only thing that's the exception is your IP address, because you're going to do a round trip with the browser anyway, or whatever the HTTP client is. You can assume that like server remote adder, that key in the server global, is the actual IP address that the server's talking to. That doesn't necessarily mean the one that the person uses.
You've got to think of proxies and things like that.
Yeah, I've seen some weird instances where people tried to detect like the Cloudflare forwarding IP address to like overwrite the remote address of the person that's talking to them without checking that the IP address that they're actually seeing is from Cloudflare. So you could send a header and just pretend that you're someone else, and their server, like all their logging from that point on, would just blindly trust it and go, oh yeah, this is coming from Pakistan. It's just sitting there not even bothering to use Tor.
The other ones is things like I've seen like X forwarded for, and just passing that in. And, typically a stack will have and use that, but maybe they'll allow in, just pass through the front door. If you've already got X forwarded for, keep it. And you can kind of play around there.
Yeah, if you send like a 10 IP address to a lot of corporate internet sites, you can usually just bypass a lot of the stuff.
Surprisingly effective. I've seen people, like it's those kind of things like that where you're like, oh crap. And it's like, because it's interesting, like Amazon's, sorry, this is Italian, CloudFront, they will keep that. They'll honor say, yeah, we'll keep the X forwarded for, but at the end we'll append the real IP address it came from. But it all depends on how your search rules for that X44 are to actually bear that in mind of what actually really was the IP address that it came in. You can really mess around with those headers. And there's obviously the forwarded header and the X44. And you can, play around with the two different ones to kind of, see what goes through and pretend that you're a proxy in that chain.
Yep. There's a lot of fun you can do there. It's not so fun on the other end of things where it's like, oh, well, we thought this came from this IP address, but they actually lied. And now our logs are completely forensically useless. That's never a fun position to be in.
Oh, no. So you say that you can't trust the MIME type, you can't trust the file extension. And then, so like kind of, how do you, so say fictitiously, I want to upload an image. I want people to be able to upload images. I want them to be able to display these images. How do I do that safely? I know that you mentioned, like you've discussed in the past, like SVGs, allowing for some bizarre reason JavaScript to be executable within them. These kind of things like that, how do you treat them as just files as opposed to executables and things like that?
So that was the other part I was going to get to, was actually serving the file after you store it, which you have to decide where to store it. Rule of thumb, it never should go in public HTML or whatever your document root is. It should always go in a directory that's a sibling to that directory. So if you're in like /home/example.com/public HTML, and that's where your URL requests go, /home/example.com/uploads or images or whatever your framework or whatever calls it should be where your files go to. And that's the part that should be, world writable for your file uploads. And then it's like, okay, well, how do you download them? And then you'll have a lot of people who have like split opinions on how to actually implement downloading the file. Personally, I don't see too much of a performance overhead to just do an access control check, because I've built systems, including Airship, where if you upload a file, you can upload into a directory, and then you can put access controls that only let certain users access anything in that directory. And this is all remotely done by the PHP, by the way. This is based on like URL paths. I can go more into permissions and access controls later, but for the time being, it does all of the whatever checks, making sure you're logged in, sends security headers like content security policy, and then it just, it sends the file MIME type that it, actually is the file content. The server will actually look at the file and say, okay, well, we're going to send like a image JPEG, and if it's not in this whitelist of known trusted things, we're just going to send it as like text plain. Never serve an HTML file, by the way. That's how phishing happens. Then, you have a URL, PHP script that will just read the file and serve it to the user. I use read path. I know the naive way is to echo file get contents, but read path is a little bit faster. So that's the general idea, is that you proxy the file to serve it to users through a PHP script or some other programming language equivalent. And you never store the files in a way that can be accessed directly, because as we've seen with a lot of I think it was even the Tim Thumb exploit that hit WordPress a couple of years ago, you can upload JPEG files that have EXIF data that contain PHP scripts. And if you access them directly and mess around with some of their settings, usually htaccess, you can get a JPEG image that when you access it, opens a reverse shell to a server out in the world. And then they can just take over your server.
What actually is a reverse server? Because I do see these kind of things. When you say you put something on the server and you're able to, was that actually able to access that box then?
So you know how you can SSH into a server? You can access a shell. A reverse shell is like an exploit file, like a PHP script or something equivalent. I've seen Perl and Python scripts from here and there that when accessed will connect back to a server and execute any commands, and it will actually spawn a process usually that the TTY for that session, that terminal session, is then assigned to. So, if you click on this image, it will spawn a PHP, the PHP script will run. It'll spawn a terminal session that connects back to some IP address in Uganda. And if the person who runs that server now knows, oh, hey, we have another server, that's connected to us. And then they can just, it's almost like they can SSH in without SSHing in because they have that process running in the background. Some of these are simple, like it'll run the existing shell. Some of these are full-featured shell implementations where they actually spawn a process that sits there and sends polls back and forth to the server, to like some API, and then goes, oh, I have, a workload to do. And that's where botnets come in.
So I suppose it's how big the payload actually can be then.
I've seen megabyte exploits, but that's because of code obfuscation.
And so, for moving on from file uploads, we're back to kind of in a similar vein to SQL injections, playing around with data and code again. It's like cross-site scripting attacks. What actually then is a cross-site scripting attack?
Generally, it's the ability to execute JavaScript on the browser that was not intended. There's different variants. Like you have stored where you like set your display name on like a user list to like script tag alert, XSS, and then if you do the users page on the website you're doing your test on, when you load the page, suddenly a box will pop up with an alert that says XSS in text. That's usually a trivial example people use as a proof of concept. But you can do really subtle, transparent things, especially on websites with a lot of traffic, like advertising networks. If you put a keylogger, obfuscated, whatever you want to do on a web page that serves advertisements, it's going to blend right in with the traffic that's already being generated.
How prevalent do you see cross-site scripting attacks now? With like the advent of like Blade and Laravel and Twig and all these things and all these different like HTML purifiers, if you want to make sure that you want a filter subset of like HTML itself, these templating languages, they're definitely a benefit, I'm right in thinking.
Oh, yeah. So one of the biggest things that templating languages let you do is what's called content-aware escaping. If we circle back to prepared statements, that's actually a very easy problem to solve. You take your data, you take your instructions, your query, your code, and you send them separately so they can't pollute each other. Like there's no cross-contamination, they're separate, they're isolated. You can't do that with cross-site scripting because when you access a web page, it's sending you a large blob of HTML, a large thing of JavaScript, CSS, images, all in one bundle usually. And there might be, references to other files like link headers. But if you have JavaScript on the page, or you have an HTML attribute and you're escaping for HTML meta characters, like the less than and greater than signs, but you don't escape double quotes properly, you can actually inject something into an attribute. So it's kind of a tougher problem to solve from a fundamental approach. What's cool about like Twig and Blade is that you can actually say auto escape in the HTML context, and then whenever you're taking any data from like the database or user input, you put it in the template. You can actually say, but escape this one in an HTML attribute context, or escape this one in a CSS context, and that allows you to
be context aware again.
Exactly. So it is a step in the right direction. I think a perfectly provable security model would be to pre-render like a template and then send the data afterwards. But that's not really how most web development's done these days. And
so that would be in a similar vein then to the whole prepared statement model, wouldn't it?
Exactly.
Where you've got the data first, the code first, and then you provide the data.
Exactly.
That's awesome. And then moving on from there, then you've got the other cross-site request forgery. Frameworks help a lot around these type of things, automatically including this type of stuff. Cross-site scripting attacks where you've got, vanilla PHP and then a mesh of HTML. You're typically, you're having to do with it yourself, but then languages and Twig, Twig templates and Blade, etc., they kind of help that way. And also then the cross-site request forgery, they allow informed context, to be able to add these, implicitly. What actually then is a cross-site request forgery?
So a cross-site request forgery is where you either through an image tag, some third-party web page you can execute JavaScript on to like submit forms transparent in the background. Through some means, you can create a request to a web page, and in doing so, you can actually execute commands that the user has access to as if you were the user. So, for example, this is a very common one in routers. if you send someone to a web page, a web page either embedded in an email or like you trick them into clicking a link that will have a forum with an auto submit attribute that sets the router password for remote access. It enables the feature and sets the password to something the attacker controls and then submits itself. So then they get your IP address and then they have access to your router so they can remotely control it all in one go. So the way that cross-site request forgery is prevented is what's called challenge response authentication, where you have a random value that's a secret, known to the server, and also put in the forum as a one-time token, as a hidden attribute. And there's different limitations. Some people do per form tokens. Some people do like per session tokens. I wrote a library called Anti-CSRF that allows you to prevent what's called replay attacks. But generally, you have a token that's called the CSRF secret that's in the forum data, like the post or get data, that's also stored in the sessions somewhere. And that's not included anywhere else. It's not in the URL. It's not something that the attacker can guess. It has to be a secret. And when you get forum data, the first thing you do is you check the token. And if it does not match, you reject the entire request. You can either give them a 500 error, you can redirect them back to the forum with an error message. However you handle it is a little bit depending on what your UX goals are. But generally, when you encounter one of those, it's a security vulnerability attempt. So treat it as such. Log it. If it keeps happening, then you know that either you have a victim or you have something else going on that requires investigation. It's not like a direct attack, like a SQL injection. You should not block the IP address because this is probably some person who's being attacked, not the person attacking you.
And then another one, kind of following on, and we've already discussed this actually quite a bit, is cryptography. You're a big proponent of, and you did a lot of work on, was getting libsodium into PHP 7.2, and I think you deserve a lot of praise for that. And getting rid of mcrypt. I'm just wondering, kind of like, what is libsodium for the audience, and why was mcrypt so bad, and kind of how has this helped PHP, in the security vein?
Okay, I'm going to start with mcrypt just because, I'd rather get the bad out of the way. So mcrypt was a cryptography library that implemented basic ciphers like AES and Twofish and Serpent, and also included some old ones like Blowfish and, the disk encryption standard from old DOS days. It got abandoned, I think, in 2003 or 2006, somewhere in that time frame, but it has definitely not been touched since 2007. And the developers actually went on to work on GNU TLS. At least some of them have. But it was, back in the day, it was like the primary library people used to like encrypt data. There was a couple problems with it. First of all, like the code had not really been tested that well, especially on 64-bit platforms. There was a cipher called Ghost, which is a Russian cipher. And they have, most ciphers have something called an S box, a substitution box, which is used for basically figuring out how to do like a substitution, like A equals 1, B equals 2 kind of thing, depending on what the cipher's specific design is. And the S box is usually like it's not always a permutation of numbers, but usually it is like, it'd be like 5, 12, 13, 6, 2, 7, 8, 1, all the numbers between 1 and 16, or maybe 0 and 15 in a seemingly random order. mcrypt for years has been using, it's in one of the places, the standard had 12 used everywhere else, and mcrypt had 2, and nobody caught that for like ever. So there wasn't a lot of actual testing of integration. Remember how I mentioned the padding where you would use, if you had 1 byte left over in a block, you'd fill the block with 15. They filled it with 0 bytes by default, like null bytes. So that led to a lot of weird things where people would like trim the padding when you decrypt a block with a message with mcrypt, and you'd lose data at the end of it, so you weren't actually getting what you put into it. And also the API was not really user friendly for security. Like most people would use what's called Ecb mode, where each block is encrypted with a key independently, and that's it. So if you have a large message with a lot of structure to the data, you'll get repeated blocks. This is called the Ecb penguin, where you would take the image of the Linux penguin tux, and you would encrypt it with a random key using AES and CBC mode, and you can still see the penguin in the encrypted output. And people, the problem with Ecb mode isn't that you can see the penguin, it's that it's not what we call semantically secure. It's not indistinguishable from randomness because, each block is 16 bytes of data. But if you have the same key and the same input, you're always going to get the same output. It's deterministic. So, there's a lot of shortcomings to the library. The fact that it was abandoned means that things like the broken Ghost cipher and the fact that their AES implementation didn't use the new AES NI instructions. AES, the standard cipher that most people use for TLS, is vulnerable to what's called a cache timing attack when it's implemented in software. A cache timing attack is basically you have data, is it in the L1 cache on your processor? If not, it'll take longer to pull it from RAM or from a higher cache. You can actually use this to leak data about secrets that are used in table lookups for something that's programmed in C or assembly. So the software implementations people did of AES did exactly this. It would take round keys, which are derived from your key for each round of the AES process, and it would actually do, for the S box, it would do a lookup to figure out, where to move things to. And there was a lot of research into this. Dan Bernstein, one of the people who wrote a library called SALT in ACL, which was the predecessor to libsodium, he actually was one of the co-authors for a paper that did a attack against AES, exploiting this to recover the secret key, and I think it only took 65 milliseconds on commodity hardware at the time. Side channel research is a huge field. There's not a lot of people in it, but there's a lot of wealth of knowledge. It covers a lot of areas.
Meltdown and Spectre come to mind with side channels.
Yep. So one of my friends, Taylor Hornby, he runs, diffuse security, like bomb diffusing. He actually did a talk at Black Hat 2 years ago about using what's called a flush plus reload attack, where you put data in the L3 cache. The software over there does it. You flush it and you reload it, and then as the software is running, you can see based on timing information if the data you put in there matched what was the software was expecting. So you can actually use this to figure out to learn when certain things happen. And he actually built a script that could tell which of the top 100 Wikipedia pages you were browsing on Firefox just by being in a completely unprivileged process, doing the flush and reload process, and then checking timing information. So Specter and Meltdown were almost variants of the same idea. Processors since I think 1995 had this thing called speculative execution, where reading data from the L1 cache takes like half a nanosecond because it's built to the processor right there. It's very accessible. So that's very fast. Pulling data from the L3 cache I think takes like 500 nanoseconds or maybe a microsecond depending on the CPU. So that's a huge timing difference. And pulling data from RAM actually takes a lot longer. I think that takes up to that's definitely in the microsecond range, which might sound like really small time intervals, but consider how far light moves in that time. You have software that's doing something, and then you get to a conditional. There's a branch in the road. There's an if statement. Okay, well, if this is true, it's going to do one thing. If it's not true, it's going to do the other. So what speculative execution does is, for the sake of speeding things up, it says, okay, I asked the L3 cache or RAM for some data that I need in order to execute this condition or some other part of the processor that's running at a different clock speed. It's going to take some time before I get an answer. So what I'm going to do is, they have this thing called a branch predictor that, as you cycle through a program, it learns, okay, well, this is usually true or this is usually false. So it'll hit that condition and go, okay, so, it's usually true. So I'm just going to proceed executing. I'm going to make a save point, and then I'm going to proceed executing the instructions until I know the answer. So that's what speculative execution is that your CPU, which is very fast, waiting for an answer from some part that takes a long time to communicate, comparatively, will continue down a branch with a save point in mind. So that way, if that turns out to be false, it can just discard that data and then, start back over from where it was and continue down the branch that it did not predict. And there was actually an old Stack Overflow question: why is my code slower when I use rand in an if condition? And it literally came down to this branch prediction misses. And by the way, the branch prediction is also another source of side channel attacks. There's a standard called crypto coding. It's on cryptocoding.net. It's the cryptography coding standard, and I think that's like the number 3 thing they mention is avoid branches in your code, just because of stuff like this. Meltdown was the Intel-specific one. Spectre's the more generalized one that works on all processors that have really been tested. It uses the fact that there's speculative execution to leak data about other processes, including, I think, Linux kernel was in the proof of concept.
And I know now that, because obviously there has been the mad rush of getting kernel patches out, but the way that they've had to solve it obviously is not ideal performance way. Obviously, there was, the registry came out with like a 30% hit as a crazy number, but there's definitely things now like certainly in the Linux kernel of having something called the PCID module actually present now because of the way that you're essentially flipping between tables. It has to do this isolation now because of the fact of it, it being able to be leaked because of these side channels.
So the mitigations that are in place, they work, but they're not really ideal for performance. I think they're still researching better ways to do it, but this was kind of like this is a problem that needs to be fixed.
Do you think that there actually will be a better way? Because, as a hardware, I mean, it was funny. I think I've read somewhere, what is the best way of solving this? Well, get a new CPU is essentially the only way of doing it because of the fact that it's the hardware that's deciding to do this. Unless you kind of, make the speculative execution better in the CPU, but you can't really do that without changing the hardware.
Mm-hmm. Unfortunately, I think the answer is going to be replacing the hardware, but
the reason why we use speculative execution and things like this is to make our code quicker and make things quicker. And all this is going to do is probably end up having to make CPU slower because it's not going to be able to do this as much because of this side channel. Or maybe, the fact that because it leaks it into the cache, doesn't it? And it keeps it in the cache and in the branch predictor. Maybe it can get it out of there. I don't know.
Yeah, so I'm not a CPU engineer, so I don't know what the answer to that's going to be, but I can kind of speculate. No pun intended. I do think that this problem is going to have to be solved by at the CPU level, like in building CPUs that don't have the vulnerabilities while still retaining, speculative execution, if that's possible. If not, unfortunately, CPUs are going to get slower. It's not going to be fun. You're going to have to choose. This is the worst case scenario for me. Is especially gamers. They're going to have to choose between, my video games, they're going to run a little bit slower. I'm only going to have 29 FPS instead of 30, or I can not get hacked. Like, whenever you give a consumer a choice between, especially when the threat is largely invisible, like they'll go to their friends and be like, hey, do you ever get hacked because of Spectre or Meltdown? I guarantee most of them are going to say no. And if you're not, in a security group, you don't have a friend who works for a security company, the answer is definitely going to be yeah. It's we never, it never bit us, so we have no reason to be twice shy. Yeah, unfortunately, that's not really a good way to approach things.
Absolutely. Sorry again for the complete tangent there. So yeah, with libsodium then, you brought this in and it's a replacement then for mcrypt. You did a lot of work with the PECL stuff and everything beforehand, and now it's officially in 7.2. So what does this mean then for day-to-day developers? What kind of, and also what use cases can I get out of this in a web application?
Okay, so libsodium isn't just a replacement for mcrypt. It actually does a lot more than mcrypt did, but it does it simpler. So, for example, I mentioned that with mcrypt, you could choose your cipher and you had to choose your mode. You had Ecb mode, which was the default that most people are probably using. You have CBC mode, which, as I mentioned before, has that padding oracle vulnerability. That's all encryption that's not authenticated. So you had to combine it with your own, hash-based message authentication code or whatever. You had to build your own protocols. It was not user-friendly in that regard. Libsodium, in contrast, is you generate a random number called a nonce, a number to be used once. You have your key and you have your message, and you pass it to a function called secret box, and boom, all of those complex steps and protocol decisions are handled for you. That's it. Problem solved, move on to the next problem. In addition to being simpler and easier to use and not having to, do protocol construction, especially if you're not a crypto engineer, it does public key cryptography, digital signatures, Diffie-Hellman, key exchange. It does public key encryption. It does what I refer to as sealing APIs, which is what it calls anonymous public key encryption in the documentation, where you take your recipient's public key, you encrypt a message, now only they can decrypt it. This is useful for if you're storing credit card numbers for long-term use and you only want to decrypt them offline. You keep your decryption key in a protected machine. You keep your ciphertext, whatever. If your database gets hacked, they have unbreakable, practically speaking, unbreakable encrypted data. And if you ferry it over to your protected machine or you have an HSM dedicated for this that decrypts them so that way you can do billing later. I don't recommend most people go through this process because that's a lot of operational complexity, but if you needed to, libsodium has the best-in-class cryptography available today to solve that problem.
And is it actually being constantly updated as well? Is that, that was obviously one of the pain points with mcrypt. I suppose you're going to be a proponent of this to keep it up to date in PHP.
Yeah, very much so. Most of the updates that are happening right now are just making it faster. Like in, I think it was 1.0.12, they shipped some updates to like the an alternative to this reference C implementation that just used optimized assembly or used 128-bit registers to do a lot of the ciphers and less operations. And generally, when you do things in less operations, you get a performance boost. There are some caveats, like I think AVX 512 actually uses more power, so your CPU goes to a lower clock rate. So that's not necessarily true. But with libsodium, you saw like a 20 to 25% performance over a lot of the implementations, like Blake 2 and Curve 25519. And every release comes with new optimizations and little features like secret stream, which is I haven't delved into the implementation details on that one because it's kind of new and I haven't really had to use for it. So it's kind of like a similar to what I do in Halite with file encryption. We have like chunks and then you authenticate each chunk and also the order of the chunks of each file. So if you do like a race condition attack against the file system, you can't use that to attack and decrypt the content without the key.
Very nice. And like you mentioned there, like nonces and things like that. And the concept of randomness in computers is always a funny one because computers are deterministic. Like, how do you make something random from something that you've told it what to do? And the idea of pseudo random number generators and stuff. And I think it'd be very interesting kind of, maybe if it's all right with you, to go into kind of like, how do computers make randomness? And like you mentioned there, don't use rand, and there's also MT rand, and then there's the new random bytes, random int and stuff. And like, what are the best ways of doing things in PHP and also actually at the Linux level? Because I know you mentioned like devu random's good.
From the PHP perspective, you always want to use random bytes, the full random _ bytes, or random _ int. Never rand, never MT rand, never unique ID or micro time or some hodgepodge combining all of those. The reason is that most of those are either predictable or have very few possible outputs, especially if you know the time of day. So randomness in general, how it's actually implemented in CPUs is actually very simple. And for something so complicated, it can actually be stated as this. You take timing information of certain registers, like microseconds or nanoseconds of when keys were pressed, or when certain file operations happened, or when network packets were received, and you take all this data, which by itself is not really reliably random, and you mix it together with a secure function, like a cryptographic function, like AES, the block cipher, or a hash function like SHA-1, or SHA-256, or SHA-3, or the new SHA-20 stream cipher. And because of the properties of like a stream cipher, if you have X bytes of output, that doesn't tell you anything about the previous or next bytes of output unless you know the key. So what the OS does is it maintains like a key, and when you ask for data, it'll start at 0 and encrypts a bunch of random data, and then it'll serve that back to you while it's constantly changing the key. So it's like you have nonsense being encrypted with other nonsense, and that nonsense is constantly being swapped out.
So I suppose the only issue there is if you know what the seed is, and you can then replay the randomness that happened.
Yeah. So that was a problem with cloud environments back in the day. Nowadays, when you launch a virtual machine, the hypervisor should read its own devu random implementation and use that to seed the VM whenever it launches one.
Man, I never even thought about that. That's so true.
Yeah.
The amount of things on the same hardware, it's reading the same exact thing. What does then devu random do? Does that actually, because under the hood, as well, like with random bytes and things, does it use, say, devu random if it's in a Linux environment? And I guess then that it uses like network packets, etc., to get this source of, this seed randomness.
Yeah, devu random, it literally just uses what the OS gives you. Different versions of Linux, different versions of Windows, Mac, whatever you're operating on, will have a different, what they're doing behind the scenes for how they get the randomness. But generally speaking, if your OS's random number generator is broken, it's game over. Everything else about your system is also insecure. So if we take that attack vector off, let's assume your OS's random number generator is reliable, it's secure, and you use that, which is what PHP's random bytes does, is it actually will pull from if you have a newer Linux kernel, the get random syscall. If you're not, it'll just read from devu random, which is the device character file that's in the dev directory, that when you read data from it, it just gives you output from the random number generator that's maintained by the operating system. If you're on Windows, it uses something called I think it's RTL get random or something like that. It's been a while since I've messed with the code. It's the Windows equivalent of get random 2.
And because I know there was discussion about throw, because I know that there's not a sufficient source of randomness, it will throw. Yeah, which is the right thing to do, because you'd prefer it to break than be hidden silently and secure.
Exactly. So there was actually a big debate about this, and this was actually like the first thing I really did with PHP internals was when random bytes was being suggested by Sammy K. Powers, and I forget who his co-author was on. Sorry about that. He originally wrote it to where if it couldn't read from dev-random, it would return like false or null. And, that was just to be compatible with how rand and mtrand work. If something fails internally, it returns a falsy value.
But then that can be changed to 0.
Exactly. So I, included a proof of concept, like, okay, let's assume this is going to return false or null. And you have like a password generator that uses random int. And it's like 0 to the maximum number of characters, and the random number fails, your password is like A. Not exactly hard to guess there. So, I made the argument, and eventually a late stage RFC was drafted and approved to change it to throw an exception if your OS doesn't have a secure random number generator available, which is very common in situations like FreeBSD jails or just misconfigured hosts.
Obviously, if your application, it's looking after it, but it's also looking after your whole host system, because it's saying you probably don't have a sufficient, and users say, like, if you don't have a sufficient source of randomness for me to be able to work on, your whole system is pretty much toast. Yep. So it helps either way, in my opinion, as well.
Yeah, so there was a couple of things that could be done there. We could have it fail open, like the initial draft, which was, you'd end up with a password that's all like index 0 repeated. Then you have the whole, fail closed. If it fails, just die the script. But then that makes developers not want to use that function at all, because now it's a source of instability. Oh no, what if I deploy it on a server that, doesn't have it? Now my code dies silently or with an error message. And it, that freaks developers out, anything that causes a fatal error. At least that's used to freak me out back when I did hardcore, like, corporate development. Like, if it's going to kill the script and puke an error message, that's just going to be bad optics for the entire department. So they were going to shy away from that. That was my fear. So I said, throw an exception. And then there was talk about, like, well, is it exception? Is it error? Which one should it throw in which context? And I'm like, I don't really care. Like, throw something. Like, this is the best implementation, because if you do nothing, if you just write random bytes or random int and you don't have any kind of try-catch to catch anything, it'll just kill the script. Like, it's secure by default. But if you're a developer who's very conscious about optics, you can catch the exception and display a certain error page and, like, make an alert to the team, like, oh, this feature is actually broken, fix it ASAP, and then have like a, very friendly, this site is under maintenance, an error has been reported to the team, blah, blah, blah. It's a lot friendlier than like a white screen with black text that says fatal error. It takes away the fear, like the scary parts of the feature, while still being secure by default. And that goes back to the whole Avi Douglin, the security at the cost of usability comes at the cost of security. It's a usable feature that will fail hard by default, but it gives you an option to catch it, and fail gracefully. If you ever run into a condition where it will throw, if your OS is configured to have secure randomness, I think it will never fail. There was a weird bug that just got fixed in the recent, 7.2.1 and the latest 7.1 branch, where if you were on a system that get random was available, but it didn't work right, it returned the wrong return code, it would fail instead of falling back to dev-random, and that's recently got fixed. So yeah, as a PHP developer, you always want to use those two functions. If you're for some reason stuck on PHP 5, there's a compatibility library called Random Compat that's been downloaded something to the tune of like 45 million times. A lot of the frameworks use it just so that way they can write code for PHP 7 and use the new randomness interface and not have to worry about it. I know like Laravel and Symfony had their own implementations of something similar, but they were like reading from OpenSSL and that was it. And OpenSSL there was a weird bug back in, I don't know if it's totally fixed, I think it's just mitigated, to where if the process forked for some reason, like if you were in like I think it's PHP CGI environment or whatever, and your process forks, which basically means it makes a copy of itself and whatnot, you would have the same entropy pool. So Ramsey had a library call for generating UUIDs, And people discovered that they were getting, they were generating millions of these a day, but they were getting hundreds of collisions because they were building forked processes. And then your OpenSSL pulls copy between forks. So you would generate the same random number twice in a row. So random compat, if any new like vulnerabilities or weird breaks is discovered in any of the implementations that are used as a source for randomness, it will be updated to not have those. So if you're running the latest random compat, your random numbers will, I want to say, almost always be as secure as possible on PHP 5. If you're using PHP 7, just use random bytes. If you're on PHP 5, just use random bytes. But you don't have random bytes, so great, random compat, and then just write it as if you were on PHP 7.
No, absolutely, man. Again, it's another thing that you guys have done that really is just helping the community. You look through your page, kind of like all the open source projects that you do and all the interesting work that you do there, and you open up to the world. It's just fascinating. Another interesting thing, and it kind of does carry on with the web application kind of security side of things, is the concept of like a WAF. You get big systems, you get big kind of corporate systems and stuff. You have many developers, many teams and stuff. Having this idea that you have one single entry point in that can hopefully try and save some stuff. And I know that you're the company you work for, that Ward, they've got a product called Web Application Real-Time Defender. I'm just wondering kind of what's your opinion on a WAF?
When I talk about security, like application security, I'm usually talking to developers, people who are building the software that they're using. A WAF is for people who aren't building the software they're using. They're just a user of a software. Like if you're a Magento user, you might have custom extensions being developed, hopefully securely. And most of my normal advice would be, tailored towards Magento developers, people who are building plugins and themes and stuff. But if you're just running a shop somewhere and you're selling custom t-shirts or like coffee mugs with custom logos printed on them for novelty purposes, and you've got your own cool branding going on, you're focused on, you're selling your products, you don't have time, especially if you aren't a technical business, to delve into like secure patching, especially the Magento interface, or if you're running some e-commerce platform like Zendcart or any of the other ones like WooCommerce. You're not a security expert team. You're there to sell a product and you just have a shopping cart. It's a means to an end. So a WAF in those use cases can be indispensable to companies, but they're not a silver bullet. Nothing in security is. Everything has to be done in layers. You can't just say, okay, well, for example, back to the file uploading thing, you mentioned the SVG attack where you could do a stored cross-site scripting vulnerability. Because SVG is a standard vector graphics, is an XML file. If you look at its MIME type, it's prefaced with image because generally it's used to build graphics. But it's actually a document. It's an XML document, and it can include script tags, and those script tags can include code. So if you access one directly through whatever means, like you have a really blurry image that looks like there's something detailed there, so you right-click and hit View Image in your browser, you might get an image when you view it full size, but it might be doing something in the background that you're not aware of. And if it's uploaded to the site you're viewing, it doesn't violate the same origin policies. So a lot of things like cross-site scripting are still viable. You can just do it like a jQuery.get equivalent, pull the page in, grab the CSRF token, and then execute commands on behalf of the user. It's not pretty. Generally, content security policies for uploaded files, even if you aren't accessing it directly, should be very restrictive. But that's a defense. The content security policy as a defense.
How does that actually differ when you use the third parties such as like S3, which is a very popular one? You delegate it off to let S3 deal with the file uploads as well as managing them. What do you kind of have to do? Obviously, you have to be then cautious when running that, running those as well. Or do you, I know you mentioned, a while back, kind of reading and piping it through. Would you do the same manner of, manner execution there?
If you're mounting an S3 drive locally and uploading files there, but then you're serving it through like the S3 URL, it's not going to execute in the context of your browser, so you're probably safe. Like that's S3's problem. Let Amazon deal with the security of Amazon. It's if anything does happen to Amazon, like S3 gets hacked, it's probably a bigger deal than whatever's going to happen to your application for like 99.9% of users. And even if it does affect you, and you're like a big company and or you were targeted by the attack because of Amazon, you could probably get in on litigation to sue Amazon for like if they were doing negligent practices. But from everybody I know who works in or around Amazon, they're pretty good about things nowadays. Their S3 authentication is a bit weird from a cryptographer's perspective, but it's not bad. Like Amazon, any of these big companies like Google, Facebook, Amazon, Microsoft, generally they have a good security team on, they have the money for one. They can pay them like $200,000 a year to do code review, 9 to 5, 50 hours a week. So they have a lot more resources available to them. What a WAF, circling back, does is, and I'm going to talk about Ward rather than like WAFs in general because I don't know the implementation details of some of them. I know like mod security is just, it's role based. It just goes, oh, you're trying to do SQL injection, I'm going to block it. Word is a little bit, it's tailored specifically to the PHP ecosystem right now. I'll eventually build something that's more generalizable if you want to throw it as like a middleware box. So the general idea is to make it a full security suite. Web Application Firewall, intrusion detection, patch management. 2 of the 3 of those are already implemented. There's some machine learning I want to build that, let's say you have a website that has, very strict, Selenium tests. And you don't want to go through the process of, defining all these, hard, firewall rules. You can actually, enable learning mode, run your Selenium tests, and then anything that it doesn't, it will learn what the pattern of your normal traffic is and block anything that doesn't match it. So even if there's a 0 day in like the CMS you're using, like let's say there's a Drupal 8 vulnerability that allows remote code execution, everything gets passed through Word first, and it'll say, this doesn't look like normal traffic. No. So that's going to be kind of like an advanced thing, but a lot of people will find a lot of value in that. So, and on the other side, like if you have a QA team and they're the ones who write the Selenium tests, or even if it's not Selenium, like you're randomly going through like a manual testing process to verify before a code deployment is done, you can just turn Ward on learning mode, go through your normal process, go through all your checklist items, and then turn Ward off. Take your the file that it learns and copy it over to your production server. If anything, if the user does anything that's not allowed, they get an error page saying this has been blocked by our security product. You're going to learn very quickly what features your users are using that you don't expect. There's going to be, right now, another thing it does is it monkey patches security in place where it can. There's some things in certain e-commerce platforms that are not secure that using a namespace collision feature where if you have a function defined in a namespace, like let's say you're in like /symphony /whatever product /auth, and it calls the rand function for generating a password for whatever reason. I can define inside of a namespace bracket a function in the same namespace called rand that silently passes it back to random int. And anytime you have Ward installed, this function will actually be secure instead of insecure, just by virtue of it being there. So it does a lot of little tricks like that to, without being written in C and being compiled and installed as a module, just from user-land PHP code that does nothing special, like no PECL extensions, no precompiled binaries.
Interesting. Sorry, like how you kind of you do the machine learning side of things, like how you do train these models and stuff. Like, is it how do you go about that, or is that kind of the secret sauce? So I don't want to go into it too much.
That's a bit of the secret sauce. Word's not open source because it is a commercial product for e-commerce focused software, but a lot of the techniques, it's nothing too crazy. I'm not doing anything super like incredibly fancy that I can write a doctoral thesis on. It tries to do a best match for the pattern, the traffic it sees, and go, okay, well, this matches all of this as good traffic. I'm going to be implementing a mode where you can send bad traffic, so you can say, okay, always block these requests that have this, these strings. Like if you're trying to upload a file, it'll look at the MIME header and say, okay, well, we've only ever allowed image /JPEG or PNG, so only allow those. So if you try to upload something else, it'll say, oh, no, sorry. There's still some tweaking there. That feature hasn't been rolled out yet, but it's being developed and tested right now.
Hey, Scott, thank you so much for coming on the show, man. I really, really do appreciate it. It's been such an interesting episode. And I'm sorry I've been going like back and forth on different bits, but it's just because you've got such a wealth of knowledge on so many different areas of security and cryptography and stuff. It's just great to pick your brain about all these things.
Oh, thank you for having me.
Awesome. All right then, audience. Well, it's been another great episode, and we'll speak to you again next week. Goodbye.
You've been listening to 3 Devs and a Maybe. You can contact us at contact@3devsandamaybe.com or follow us on Twitter at 3 Devs and a Maybe.